Next problem. Two population have their means equal, but SD of one is twice the other. Show that the sample size 2000 from each drawn under simple sampling conditions. The difference of means will in all probability not exceed 0.15 sigma, where sigma is the smaller standard deviation. What is the probability that the difference will exceed half this amount? So they have given two population have the same mean, so let it be mu1 that is equal to mu2 which is equal to mu, right? And the standard deviation of one is twice the other. So if it is sigma 1 is 1 and sigma 2 is for other, so sigma 1 is twice the sigma 2 other. Since it is given that sigma is the smaller SD, so sigma 1 sigma 2, right, they have given. So sigma 1 equal to 2 sigma 2, which one is smaller? Definitely sigma 2 is the smaller, so take it sigma 2 which is equal to sigma, right? Because 4 is 2 into 2, right? 2 times 2, so 2 is smaller than 4, right? That is what, right? So sigma 1 is equal to 2 sigma, right? Given sample size n1 both are equal, so n1 equal to n2 is equal to 2000. x1 bar x2 bar be the sample means of first and second samples. To prove that the difference of means will in all probability not exceeds 0.15 sigma. To prove mod x1 bar minus x2 bar difference of the means less than or equal to 0.15 sigma. So test statistics x1 bar minus x2 bar by root of sigma 1 square by n1 plus sigma 2 square by n2, that is x1 bar minus x2 bar divided by root of sigma 1 is 2 sigma whole square by 2000 n1 plus sigma 2 is sigma square by n2 is also 2000. So that is equal to x1 bar minus x2 bar by root of 4 sigma square by 2000 plus sigma square by 2000. So that is equal to x1 bar minus x2 bar sigma 5 by 2000, right? So that is equal to sigma x1 bar minus x2 bar by sigma into root of 1 by 400, that is equal to 20. So z is equal to x1 bar minus x2 bar by sigma by 20. We know that in all probability standard normal variate lies between plus or minus 3. So z lies between plus or minus 3. So z value is x1 bar minus x2 bar by sigma by 20, that is less than or equal to 3. That is x1 bar minus x2 bar less than or equal to, taking that sigma by 20 to the right hand side, it will go to the numerator 3 into sigma by 20. So x1 bar minus x2 bar less than or equal to 0.15 sigma. Hence in all probability x1 bar minus x2 bar is less than or equal to 0.15 sigma. To find the probability that the difference will be exceed half of 0.15 sigma amount, right? Not exceed. So first part is we need to prove difference of means not exceed 0.15 sigma. Then second question, what is the probability that the difference will exceed half of this amount, right? So to find probability the difference of mean exceeds half of 0.15 sigma. So probability of the difference of means exceeds half of 0.15 sigma, that is probability of z is greater than 0.15 sigma by 2, right? So probability of z is x1 bar minus x2 bar by sigma by 20 greater than 0.15 sigma by 2 into sigma by 20. So because modulus x1 bar minus x2 bar is greater than 0.15 sigma, right? Difference of mean exceeds half of that value, right? So dividing both inequality by sigma by 20. So probability of mod x1 bar minus x2 bar by sigma by 20 greater than 0.15 sigma by 2 into sigma by 20, right? So next, that is z, right? So probability of mod z greater than 1.5. So the So we know probability of x is greater than a. This can be written as 1 minus probability of x less than a, right? Probability of greater than plus less than equal to 1, we know, right? Total probability, right? So 1 minus probability of mod z less than 0, 1.5, right? So 1 minus probability of, so z lies between 1.5 less than 1.5 means minus 1.5 to plus 1.5. That is the meaning, right? Minus 1.5 less than z less than 1.5, right? So 1 minus area lies between minus 1.5 to plus 1.5. That is 1 minus area lies between minus 1.5 to 0 plus area lies between 0 to 1.5. So we are splitting. So because minus to plus you are having 0. So minus value to 0 1 area. So 0 to plus area 1 area, right? That means 1 minus probability of minus 1.5 less than z less than 0 plus probability of 0 less than z less than 1.5, which is equal to minus 2 into probability of 0 less than z less than 1.5, because area, if it is in the negative side or positive side, so both will be same. Area is always positive side, right? So if you are having area between minus 1.5 to 0 is nothing but area between 0 to 1.5. So we can replace probability of minus 1.5 less than z less than 0 by probability of 0 less than z less than 1.5. So you will get 2 times, right, by symmetric property of the normal curve. So from the table you will get the value. So 1 minus 2 into 0.4332. So that is equal to 1 minus 0.8664. That is equal to 0.1336. Next problem. The following data are got from an investigation. Group 1, Group 2, number of items 5075, mean, right, 181.5, 179, standard deviation 3.6. Find out whether the two means differ significantly, right? So given, so sample size n150, n275, x1 bar 181.5, x2 bar so 179, s1 equal to 3 and s2 is equal to 3.6. So hypothesis, there is no significant difference, right? We are taking mu1 equal to mu2, and alternate hypothesis, there is a significant difference, that is mu1 not equal to mu2, 2 tail test. Here level of significance they have not given, we will take 5%. So test statistics z is equal to x1 bar minus x2 bar by root of s1 square by n1 plus s2 square by n2. Substituting these values, so 181.5 minus 179 by root of 3 square by 50 plus 3.6 square by 75. So after simplification you will get 4.209. So we take the modulus value. The calculated value is nothing but modulus value. So here it is positive only. So 4.209. So tabulated value of z is 1.96. Comparing these two, calculated value is greater than tabulated value, right? 1.96. 4.209 is greater than 1.96. Therefore H0 is rejected. So H1 is accepted. Therefore there is a significant difference. Thanks.